going on, guys? Let's do this problem right here. So we have first problem that is asking at what rate will a pendulum clock run on the moon, where the acceleration due to the gravity is 1.63 meter per second square if it keeps time accuracy on the earth. That is, find the time it takes the clock's hour hand to make one revolution on the moon. So let's see how we can find it. So first of all, this is a pendulum clock. So we know the period of this pendulum clock is going to be T E due to Earth is going to be equal to 2 pi over square root of L over G E. E refers to the Earth, but in this case we are dealing with the moon, so the moon question is going to be same thing, but the only difference is that period and the acceleration due to gravity is going to be related to moon. So if I create equation, this is going to be Tm is equal to 2 pi square root of L over Gm. To find the ratio, what we have to do, we simply divide Tm by Te, and if I divide, I will cancel 2 pi and L. The only thing that is left is so Gm. So we are dividing by Tm by Te. So Ge is going to be on top, and we are going to have Gm in the bottom. Now we have the gravity. We know that gravitational acceleration due to gravity in the Earth is 9.80, and this is provided right here in the moon. So if we divide both of them, that gives the ratio. So let's do this. So this is going to be 9.80 divided by 1.63, and if you find the value, that gives us 2.45. That is the ratio. And then they are asking that if is find the time it takes the clock hour hand to make one revolution. So in the Earth it's 1 hour, but in the moon it's 2.45 times slower. So it's gonna take 2.445 hour for it takes to the clocks to take one revolution in the moon, and that's how it's done. And the second question, it's asking radio waves transmitted through space at 3.00 times 10 to the power of 8 meter per second by the Voyager spacecraft have a wavelength of 0.120 meter. What is their frequency? So it's look like straightforward because we have the velocity right here, 3.00 10 to the power of 8, and we have the lambda that is provided 0.120 meter, and they are asking to find the frequency. So we have the equation V is equal to F lambda, and from this one we can find the lambda frequency. So frequency is going to be V over lambda, and this is going to be 300 times 10 to the power of 8 divided by 0.120, and if I divide this gives us 2.50 times 10 to the power of 9 hertz, and that's the final answer. I hope you guys like this video. See you next time.